The web is dead, and I proceeded to try to debunk that in my CyLab partner talk last year. And I think that the web is not dead. Rumors of its demise have been greatly exaggerated. This is actually the cover of Wired magazine exactly a year ago. But it is under threat, and I think that while a lot of people think that the problem with web security, which is the field that I study, is that there's just so many attacks out there, there's so many bugs, so many holes. I think that the biggest threat to the web right now is actually that it's falling behind compared to other platforms for software. There are lots of closed platforms, proprietary platforms that are doing quite well right now. If you look at the Apple App Store, the Android market, even desktop platforms, those platforms are able to innovate and move more quickly than the web because of the fact that features take an extremely long time to make their way through standards bodies. And a lot of the reasons why features take a really long time is because it's very hard to get the feature right. You can only get one shot at it in the world of web standardization. So our research group at CMU's Silicon Valley, which is where I'm based, is looking at the way that HTML5 is evolving and trying to find ways to accelerate the progress of the web by eliminating a lot of the concerns that researchers and vendors have about security and making it easier for them to analyze these features. And so just to give you an example of a feature that has been around for a long time in plugins but hasn't made it onto the web, there's this camera access feature which you can use to do all sorts of interesting applications on the web. And I think that we're going to see in the next few years the camera really flourishing as a tool for online collaboration. But it's been very, very hard for vendors to get that into browsers, and a lot of that has to do with security concerns. So the research that we focus on at CMU Silicon Valley is really aiming to be extremely practical. We want to get our ideas into the hands of billions of users. Every single web browser should adopt the proposals that we work on. So we're looking at really big ideas that are going to get into the hands of a lot of people. When you're thinking about research proposals for improving web security, it's easy to design stuff that sounds good in a lab, but then when you actually hand it off to a vendor, it doesn't get adopted. And there are a few criteria that vendors use to decide whether or not this is a feature that they're interested in adopting, and I'll get to that in a minute. We've set up this online website called browserscope.org. You can go there right now and test your browser, see which features that have been proposed have been adopted by your browser and which ones are still in deployment. It's a crowdsourced site, an open source community project with Google. And it's very interesting to see which features do extremely well on BrowserScope and get adopted in the course of a couple of years, and which features end up languishing and taking 10 years or more before any vendor picks it up. So what I've noticed in the course of looking at the way that HTML5 has evolved is that there are three criteria that really are necessary in order for a feature to get broad adoption. It has to be a feature that replaces something that people desperately need. Right now, people are using Flash Player to access the web camera, even though plugins are really designed more for playing movies and media content. So they found this hacky workaround in order to get it to work, but it's extremely difficult to use, and the API is proprietary. It has to be easy for the browser vendors to implement. If there's a lot of complexity to it, or it's not clear whether or not the feature is secure, the browser vendors are skittish and they'll wait, and they'll try to wait until the feature is going to be easier to implement. And finally, you need to make sure that when you're deploying these features, they have to be low risk, so they don't actually have any danger of breaking existing applications, because then vendors will be afraid to put it in their next version. So we've developed some tools at CMU Silicon Valley that are designed to help browser vendors evaluate security features and designed to help good ideas make their way onto the web and into the hands of billions of people. So one thing that we've developed is an alloy model for the browser and for the web, and we can use this to take a new proposal and run it through our system and automatically find attacks that a human might not be able to deduce just by looking at the specification. And when I was here a year ago, I pitched to you a proposal called app isolation, which sounded like a great idea to me, being a web security researcher. The idea was that, a lot of people use two browsers for browsing the web, one for doing their banking and one for doing all of their other browsing. And it turns out that you actually get some pretty decent security out of using two browsers to browse the web. Well, what I didn't know was that there were a number of subtle flaws in my idea that weren't discovered until we ran it through Alloy, and then we found that there were all these interesting corner cases that we hadn't thought about that a model checker was able to automatically find. So after we used Alloy to find and fix these vulnerabilities, we can now have a lot more confidence in the security of this new proposal. Another thing that we've developed at CMU Silicon Valley is an ad-based research platform. What we do is we take out rich media ads on online advertising networks, and we typically do a fairly small ad spend, about $150. And when you do that, you can get hundreds of thousands of impressions and run large-scale analysis studies to determine the behavior of browsers, of plugins, of network intermediaries. We've been running a lot of really interesting studies using this particular technique that have had a real impact on the world. And it's really great for doing compatibility analysis. Let me tell you about one of the experiments that we ran using ad networks that had a huge impact over the course of the last year. So we ran an experiment using ad networks to detect whether or not network intermediaries had any unintended interactions with a new protocol that was being developed called the WebSocket protocol. What we discovered was that there was a very serious protocol issue that would cause network intermediaries to be confused by this new protocol and begin leaking the user's secrets to the attacker. So this led to an emergency patch by all the major browser vendors. And fortunately, we caught this early enough that there were not too many websites that were using the new protocol. And the vendors were actually able to roll out a breaking change. If we had waited 6 months or a year to fix this issue, it would have cost millions of dollars and broken all the websites on the web that were using this new protocol. So even when a feature makes it into green on browser scope, meaning that it's been adopted by all the major browser vendors, there's still a lot of additional work to be done because the feature may not cover all of the corner cases that you're interested in. And let me give you one example. So there's this feature that was adopted by browser vendors over the course of the last year called X-frame options. And it's designed to prevent one of the most easy to pull off attacks on the web, clickjacking. Clickjacking has been all over the news lately. There's lots of really interesting clickjacking attacks that have been demonstrated. And the attack is extremely simple. You just build a website, you get the user to come to your website, and you have them click on something. And what they're actually clicking on is something they can't see, which is a button that has some dangerous effect. Launch the nuclear missiles, delete my Twitter account. Maybe those aren't equal in importance, but you get the idea. Any action that the user can take on any website, you can force the user to do without their knowledge, simply by creating an iframe to the website that you want to attack the user on. And so this has got a lot of fairly major consequences, and the X-frame options defense was created to resolve all of the broken defenses that individual websites were trying to deploy that didn't work. It was a success story because it was so easy and low risk for the browser vendors to adopt, and it was clearly a must-have solution that they all really wanted. But there are still lots of really great ideas that are not possible because clickjacking exists, and they aren't being solved by X-frame options. So I'll give you one example of an attack that we discovered. So if you set up a website and you get the user to click on something, you can have them click on a Facebook like button. And that might not seem like it's such a big deal. I mean, who really cares if you like something or not? But that's actually de-anonymizing the user. When the user clicks on it, they get added to the list of people who like that thing on Facebook. And so you can immediately determine their identity. But the user won't actually see this like button. It's invisible. It's happening entirely without their knowledge. And so this has a lot of ramifications in countries where the user's anonymity is very important for protection from government. It's also got a lot of other consequences as well. So there's a number of other things that you can do with a clickjacking attack besides making a like button. So you can have the user click through an OAuth dialog, which would allow the attacker access to their email. Lots of people have very sensitive things in their email, and they may not want to share that with any website that they go to. We've run user studies showing that you can actually trick the user into clicking on this button via a clickjacking attack. PayPal is trying to roll out a new payments platform with one-click payment, so you can actually buy stuff when you're on another website. That's something that you definitely wouldn't want the user to do unless they saw what they were agreeing to. Adobe Flash Player, of course, has their permissions dialog that you have to click on every time a website wants to enable your camera. If you could trick the user into turning on their camera without their consent, that could be used against them. So none of these applications can use X-frame options. X-frame options is a defense that was designed specifically around iframes. But unfortunately, some iframes need to be embedded into third-party websites. And for this sort of mashup, where you have an untrusted website that's embedding some content from a provider that you trust, it's extremely hard to defend against clickjacking attacks. So we've been doing a bunch of user studies, mostly using Mechanical Turk, but also some in-person studies, to try to study all the different defenses for clickjacking and find a defense that has an acceptable security and usability trade-off. That'll enable these websites to do things that they could never do before because of clickjacking. So I just gave you a flavor of some of the research that we're doing at CMU Silicon Valley, and I hope we'll have a chance to talk about some of this research more during the panel. But I just wanted to sort of emphasize the main research themes that we have here at Silicon Valley. We're using model checking to enable the standards bodies to standardize protocols faster without having to worry about attacks. We're using ad-based research to validate our attacks, validate the compatibility of our defenses. We're using human factors testing to determine which defenses have the best usability and security trade-off. And then finally, we're trying to enable things that were never before possible in the web and ensure that it remains competitive with all of the other platforms that people are using to develop software. So, and with that, I'll conclude my talk. Thank you very much.